Thank you for joining us. This is the CNC Tailstock team for Senior Design 1. My name is Ashley Chapa.
I'm Dylan Erickson.
I'm Walter Friesel.
I'm Nathan Pennala.
The objective for our senior design is to create a tailstock that mounts onto the current lathe that's in the machine shop. A tailstock helps reduce the vibration on a longer workpiece by supporting it on the other end. Currently, the tailstock that we have does not have a long enough travel distance, and we are looking at one that is going to be able to be mounted on permanently to the CNC lathe and reduce the vibration of the piece.
Here we have our current state tailstock that currently mounts onto the Tormach lathe.
Here are the customer requirements. They want to have at least 12 inches of travel or try to utilize it as much as possible. Have a shorter changeover time. It is also important to have minimal vibration. Some of the engineering characteristics we came up with.
Here we have our house of quality. It ranks our customer requirements along with our engineering characteristics.
Here we have our condensed product specification. A few things to point out. We have a product deadline by the end of next semester, which is going to be mid-December. For the life cycle of the product, should be just the life cycle of the lathe. It's likely to be cast iron, which will last a long time. Our budget, we have a current budget of about $1,000. That's about the cost of the current Tormach lathe, Tormach tailstock, excuse me. And for fabrication, we'll save a lot of costs by using the MTU foundry and the MMET machine shop. Based on our engineering characteristics, we came up with 4 potential designs. All of them are cast iron, and all of them use a manual ram engagement. They vary slightly, and the way we decided to use which one we used was using something called a Pew selection matrix.
Okay, here we have our Puke selection matrix, which shows our process of going through and selecting the best design.
What's circled in red here is the track that the tailstock will mount onto. Since we decided to go with design number 2, we've just done a basic CAD model of it using the dimensions from our existing CAD models provided by Tormach. It'll be in 2 parts. The base will all be mounted in one. The body, which is will eventually be shelled out to reduce weight, and we'll have the actual tailstock ram assembly put on top. We are yet to do a FEA analysis on here, but we'll just have 2 screws for now holding the body to the base.
Here we have our Gantt chart. This was created before the unfortunate shutdown of campus, so things are subject to change. What did say the same here is what's shown in the chart. What's coming up next for the tailstock team is that we are going to model the tailstock head. We are also going to 3D print the CAD models to see how it fits in 3D space and basically use that as a dry fit before moving on and casting the whole part. We are also looking at modifying the current lathe to make accommodations for the new tailstock for mounting purposes.
Last thing we need to say a few thank yous to Nicholas Henderson, who is our faculty advisor, the MTU MMET department, which is our sponsor, and then Tormach, the manufacturer of the lathes, who helped provided the CAD models and support. For any questions, go ahead and email me at whfriese@mtu.edu.